Hey everybody, Mr. Bowman here. This is another 2.7 calculus video. In this video, we're focusing on all the merit questions for the 2024 exam. Just a reminder, all these questions are past NZQA exam paper questions, so I've just compiled them all in one place. If you're wanting more excellence questions like this, check out the link in the description, and that'll take you to all of the questions from, I think, about 2015 onwards. So let's get straight into question number 50. So basically, two-part question. We've got the gradient function here. The first question is to find the equation for fx if it passes through 1, 0. So let's get into that bit first. Actually, let's get rid of that bracket there and put in an I there. So the way I normally do these questions is I'll come up and figure out the straight line formula using y equals mx plus c. So I can see the y-intercept there is plus 1. And if I use a kind of like a rise over run approach, I can see make a triangle there. I can see it rises 1 and it runs 2. That means I've got a gradient of 1/2. That means my formula, my f dash x formula, my gradient function is equal to 1/2 of x plus 1. So I've got that there. As I'm finding out fx, I need to integrate this function here. And the integration is going to be a bit annoying because of that fraction there. But fx is going to be equal to, remember, it's your coefficient, which in this case is 1/2. Divided by your power plus 1. So we have a power of 1, so 1 plus 1 is 2. And that's going to be times by x squared. 1 will integrate to x, and then we've got our usual plus c for integration. I'm now just going to simplify that messy fraction there. And remember, that 2 there is going to drop down. So that's going to become 1/4. So it's going to become 1/4 of x squared plus x plus c. So we've got the original function here. Now we're going to look to find the full function, which is the plus c. And we know through the point 1, 0, so 1, 0 given to us in the question, that tells us that x is equal to 1 and y is equal to 0. So I can use both of this information to substitute it into my expression. That'll let me get c. So let's do that now. So I know that 0 is going to be equal to 1/4 of 1 squared plus 1 plus c. Just a reminder, 0 is y, and you can see my x is being subbed in here. So that's going to become 0 is going to be equal to, what's that? So it's going to be 1/4 plus 1, so it's going to be 5/4. So 5/4 plus c, which means c will be equal to -5/4. And once I've got that, I can now state my full function. So fx is going to be equal to 1/4 of x squared plus x minus 5/4. So I've got that there. I can now start thinking about I, which is my next part over here. And I've basically been asked to draw that function, including any intercepts and stationary points here. So the way I approached this question was I used my graphics calculator to help me identify all the key points that the graph needed to go through. And remember, the key points here were the x-intercepts, the y-intercept is pretty important, and then obviously the turning point. I'll just call that TP for turning point. And again, I use my graphics calculator to do all that for me. So I've entered in this function here to my graphics calculator, and then I'm able to navigate through that. So I found out my x-intercepts, my roots is another way to describe them, was 1, 0, and -5, 0. I then found out my y-intercept, that was 0, -5/4. Then I found out the x, also not the x-intercept, the turning point, and that was -2, -9/4. And once I got that, I plotted all those points. So my first x-intercept, I plotted that, that's over there. My second x-intercept was just over there, so I plotted that. I've then got my y-intercept, so that's going to be just below -1, which let's call that over there. It's not going to be a perfect drawing, but there we go. And then finally, my turning point just under 2, at 2. So it's probably going to be, I don't know, maybe there-ish. So now that I've got that point, you can kind of see it come off forming shape. So you can see there's the curved bit. I can do the same thing this way here. And then once I've got that, I can kind of sketch the graph up this way, and then I can sketch the graph up this way. If you wanted to be more accurate than I was, you could always come up with a few other coordinates like there and there, just to kind of see that shape a bit better. But I'm pretty happy with that because I've got the x-intercepts right, my y-intercepts there, and my key point, the vertex, is all there. So if you can do both of those questions together, that's going to get you an excellence mark. We're now on to question number 151. And 51, nice and short. So we've got a line. So it's a line going downwards, right, because of negative x. So k is the unknown y-intercept. Use calculus to show that the minimum of this thing here is equal to this thing up here. So it's going to be a bit messy, but first thing to note, let's just start by jotting down my function, and that's that x squared plus 2y squared thing. That's my function there. I'm trying to find when that's at its minimum. And luckily that y, I can get rid of that y, right? Because I know that y is equal to kx. So let's do that. So x squared plus 2, and then it's going to be k minus x all squared. Now that I've done that, I can then expand all of this and simplify that, and that'll give me a function in terms of x, so I've gotten rid of that y. There'll also be a k floating around too that I don't know about. So expanding that, so it's going to be x squared plus 2, and don't forget, this is going to be a double bracket, so I'm going to rewrite that out as a double bracket. K minus x, k minus x. I'm now going to expand this. So we've got x squared plus 2 lots of, so it's going to be k squared minus 2kx plus x squared. I can now expand that, so it's going to be x squared plus 2k squared minus 4kx plus 2x squared. Simplifying my x squareds and putting it in, x squared x number form is going to be important. So remember that kx squared is my constant, so I'm going to move that to the back while grouping the x's together at the same time, or the x squared. So it's going to become 3x squared minus 4kx plus 2k squared. Okay, so I've now got my expression x and k for the function, and I want to know, I should have mentioned this at the beginning, because it's a show question. Show means I've actually given you the answer, which is 2k squared over 3. So it's our job to get to that point. So I now need to figure out, well, how can I find the minimum of this point in terms of k? Because that's what it is here, right, in terms of k. So let's go ahead and start doing this. So I'm going to need a gradient function to go ahead and do that. So if I differentiate that, remember k is a constant or another number. So if I differentiate that, that's going to become x squared minus 4k. So at the minimum point that it's talking about, the minimum value, I know my gradient will be equal to 0. So I can set that to 0. So 0 will be equal to 6x minus 4k. And at this point here, I'm now going to rearrange. So x is equal to something to do with k. And that's going to be the coordinate of this. But I want to note it's not going to get me to that because I then need to find the minimum value. So I'm just getting the x coordinate in terms of k at this stage here. So let's rearrange this. So 6k is going to be equal to 6x will be equal to 4k. X will be equal to 4k over 6, and that there would simplify to 2k over 3. And a lot of people got confused in the exam is because it's actually quite similar, 2k versus 2k squared, but we haven't got the answer, remember. This is only the x coordinate. So to find the minimum value, we now need to substitute that back into our original function, and all of that should then simplify to find the minimum point, which is 2k over 3. So let's go ahead and do that now. So we're trying to find f when x is equal to 2k over 3. So let's do all that substitution now. So it's going to become 3 bracket 2k over 3 squared minus 4k bracket 2k over 3. And then it's plus 2 bracket, 2k. Oh no, 2k squared will stay the same, wouldn't it? So that will stay as k squared. I can now simplify both of my brackets. So that we'll leave that 3 there for now because we've got to do bed mass. So that's there is going to become, so it's going to be 3 bracket 2k squared. Well, that's going to become 4k squared over 9 minus, we can multiply that top and top there. So it's going to become 8k squared over 3, 8k squared over 3 plus 2k squared. I can then simplify, do that multiplying there, so it's going to become, 12k squared over 9, 12k squared over 9, minus 8k squared over 3, plus 2k squared. So it's looking fairly messy at this point, but what I could do is I could simplify this fraction, change this to have a denominator of 3, and that way everything there would have a denominator of 3, and I can merge those fractions together. So let's do that. So that can simplify to 4k squared over 3. So 4k squared over 3. We can go minus 8k squared over 3. And this bit here, that's going to become 6k squared over 3, right? So 6k squared over 3. And that's because that would simplify to 2k squared. And I like this because all of them have a denominator of 3 now. So now looking at my numerator, so I've got 4k squared minus 8k squared. So that's going to be negative 4 squared. So negative 4k squared. And then I'm going to add on this, and that's going to make it positive 2k squared. So I've got 2k squared over 3. And I'm liking this because I've arrived at the point I've been asked to show. And normally after these ones, you write the phrase QED, which is Latin for I've shown what you've asked me to show. So we're now on to question number 52, and I really do enjoy these kind of area under a curve type questions. I think they're quite neat. But basically, we've got a parabola of 8x minus x squared. So that's this parabola here. They've drawn a trapezium kind of within that parabola. And you can see we've got x and 2x. So basically, whatever x is, we double it to find 2x. And we've been asked to find the maximum, use calculus to find the maximum area of this trapezium. So I guess the first thing we need to do is we need to find an expression for the trapezium in terms of x. So let's start by jotting down my trapezium formula. Hopefully you remember it. They've got it down here, but I'm going to use the version I like. So area is going to be equal to a plus b over 2 times h. So the first thing to note is this trapezium has actually kind of been flipped around. The height of it is here, because you normally draw your parallel lines like this and this, and you've done that. So our one's been flipped around. So this here is our height, and our height is 2x minus x, which is just x. So noting that there is my height. I now need to find out kind of the top of the shape and the base of the shape, which would be represented by the two sides here and here, which if you go across to the y-axis for both of them, that would represent the y coordinates sitting up here and here. And remember, we've been given a function of y up here. So this bottom one here, this one's going to be really easy to figure out because it's just the formula. So that there is going to be 8x minus 2x squared. The next one's going to be a bit trickier because instead of putting in x, we're going to need to substitute in 2x. So that's going to become 8 times 2x minus 2x squared. And that's going to become 16x minus 4x squared. So I've now got the top and the bottom of my trapezium, which is my A and my B, right? So that there I said was equal to A, and that there I said was equal to B. So now that I've got B, A, and H, I'm going to substitute all three of these into my trapezium formula, and that will get rid of all of the letters apart from X, and that'll give me an expression which I can then do something with. We'll just figure out what we're going to do with that later on. So let's start subbing all that in. So A was equal to 8x minus x squared. B is, so we're going to go plus 16x minus 4x squared, and all of that's divided by 2, and then I'm going to times that by x, which is my height. So let's focus on simplifying that numerator first. So we're going to deal with the x's. That's going to become 24x minus 5x over 2. Oh, sorry, I should say minus 5x squared, shouldn't I? So put that squared back, and that's going to be multiplied by x. I can now simplify my fraction, divide that 2. So it's going to be x times by, so it's going to be 24 divided by 2, that's 12x. And we're going to go minus 5 over 2x squared, or you could have done 2.5 as well. I can then expand this here, so I'm going to have 12x squared minus 5 over 2x cubed. Amazing, so I've got that. I can now go ahead and do my differentiation. I guess the reason I'm doing my differentiation is because I've been asked about the maximum area. And I know at the maximum, a dash, my derivative, is going to be equal to 0. So by coming up with my derivative, my gradient function, I can plug that in and hopefully get some values. So I've got a dash. So a dash is going to be equal to, differentiating that, that's 24x. So 24x, differentiating that, so it's going to be 5 times 3, right? So it's going to be 15 over 2x squared. I can now set that to 0, so I've got 24x minus 15 over 2x squared. And this here is just a quadratic question, so I'm going to use my graphics calculator to do that. Remember that a is equal to the number by the x squared, so it's going to be negative 15 over 2. B is by the x, which is 24. C is the constant, and in this case, we don't have any. When I did that on my calculator, I got two answers, 3.2 and 0. And I want to note at this point here, you got to think, particularly measurement, you got to think, are both of my questions, both of my answers valid? And in this case, if you have a look down the bottom there, remember the base, the top and bottom there, x and 2x, that would be the same value. So if x was 0, that would be 0 and 0. So that doesn't make a trapezium. So we know that x cannot be 0, as x must be greater than 0 in this case. Just deleted the question to give me a bit more room for working. Now the final step of this question was to calculate the area, because the question asked us for the maximum area. So I need to go back to my original function, and now that I know that x, this works, the area of the trapezium is maximized when x is equal to 3.2, I'm going to put x equal to 3.2 back into my area function, and that will then tell me what that maximum area is. So let's go ahead and do that. So my maximum area is going to be equal to 12x squared, which is going to be equal to, so 12 times by 3.2 squared. I'm then going to go minus 5 over 2x cubed. So 5 over 2x cubed, and in this case that's going to be 5 over 2 times 3.2 cubed. And then once I've done that, I can sub that into my questions. That's going to be 40.96 units squared, and I had to round up to 2dp because it was a bit messy, that number there. So we're on to question number 53 now, and this again comprised of two parts. They did a few of these in this exam, but we've got question 53I, which we'll do, and then we'll worry about II after that, and you need both to get E. So we've got a microbiologist growing bacteria in a petri lab, monitoring the population in the dish. After a certain number of days, they would have used up all the nutrients. At this time, the population will be at its maximum. Okay, so we got the word maximum, so straight away I'm thinking something to do with turning points. It will then begin to decrease. Cool, that's some good information too. It will decrease when the microbiologist adds more nutrients. The bacteria will start to increase again. So it'll increase again. And again, I just want to note they didn't specifically mention the minimum, but that would happen at the minimum, right? So it keeps on going down and down and down. And then the biologist is giving it more food. So we've hit the minimum, and then we start going up again. So if we sketch it like a cubic maybe, so the population goes up and up and up, and then eventually reaches the maximum. That's probably when it's run out of nutrients. Sadly, the bacteria all start to kind of die until we hit the minimum population, and that's when the biologist will come in, probably put in some more nutrients, and then the population will start going up again. And we're just using this range of the cubic. It may end up doing that pattern a few more times, but the information we've got is really just relevant to a positive cubic by the looks of it. And that matched the maths that we've got here, right? Because we've got t cubed. So that's going to be a positive cubic. So I think we're on the right track with our diagram. So what is the rate at which the population is decreasing? So we know it's going to be a negative gradient at that point on day 10. So it's probably going to be somewhere in here will be day 10. Somewhere in there, day 10. So let's start by doing that. So we need a rate of change. So that's all about the gradient function. So let's find out what p dash t is. So p dash t. So we differentiate t cubed. That's going to become what? 3t squared. Then negative 60t squared. That's going to become negative 120t. And then we've got 768t. So that's going to become plus 768. T goes away. And then that constant go away too. So I've differentiated my function. I now know that t is equal to 10. So I'm trying to find the rate of change when t is equal to 10. So that's going to become 3 times 10 cubed minus 120 times 10 plus 768. And I've got that answer written down here next to me. I got negative 132. And I really liked seeing a negative sign here because that matched the question expecting a decrease. So let's put that in a bit of a small sentence. So that means 132 bacteria per day are dying in day 10. So 132 bacteria per day are dying in day 10. So we can now move on to II. And this one here took me a while, it took me a few reads of it to get it, and hopefully I'll be able to break it down for you as well. Basically, use calculus methods to determine the difference. So straight away, difference means I'm finding two numbers and I'm subtracting them. In bacteria, from when they had their dish being used up, remember, dish being used up, we were told that was the maximum, to the time they added more nutrients, and again, remember, that was when the minimum occurred. So basically, if I get rid of the lines, I made a bit more mess, that's telling us, what's the difference, or how long did it pass to go from the maximum to the minimum, or not rather how long it passed, or rather what was that drop from the maximum to the minimum that they were dealing with. So we're trying to find the two turning points, is basically what we're doing here. So at the turning points, we know that P-X, or P-T actually, isn't it, not X in this case, P-T for time is equal to 0. So we're going to substitute that in. So 0 is going to be equal to 3t squared minus 120t plus 768. I'm going to plug that straight into my graphics calculator to find my two answers for t. So remember, for my calculator, A is equal to 3, B is negative 120, and then C is 768. And then that means T1 is equal to 8, and then T2 is equal to 32. So that tells us that maximum there happened at the 8-day mark, and the minimum happened at the 32-day mark. So that means 24 days passed until the microbiologist added more nutrients for the population to kick off. So I've got the 2 points. Now I just need to find out, on day 8, what was the population? And on day 32, what was the population? And then once I got those, I can then go ahead and calculate the difference, which is the population change, so the difference. Okay, so let's go ahead and find H. So the way we do that is our very original function here, we're going to substitute t equals 8 into that, and that's going to go ahead and get my answer. So t cubed is going to become 8 cubed minus 60 times t squared, which is going to become 8 squared, plus 768 times 8 plus 40,960. And then when I do all of that, I got 43,776. So it's quite a lot of bacteria. And then finally, I repeat the same for 32. I won't do all my working there to save a bit of time. But when I did that, I got 36,684. And then to find the difference, I subtracted my maximum value from my minimum value. And then that got me 6,912. And that there was the answer that I'm looking for to shore up on your excellence grade. Okay, so we're now looking on to question number 54. Question 54 is a nice question. I always like these volume ones, but they are difficult to set up. So going straight to the question, we've been asked, a drink manufacturer is starting a new line of cylindrical cups. So that's the cylinder that they're talking about. They wish to minimize the surface area. So basically minimize the surface area means we need a function surface area in terms of something, and at the minimum, my derivative, my SA dash will be equal to 0. We've been given some information on the volume, and then we've been asked to find the dimensions. So we need to find the radius and the height of this one here. So I imagine that's quite a common error. A lot of people might have just found one of the two dimensions, but you need both. Question clearly answer that, and there are some formulas. So the first thing I'm going to do is because we're trying to maximize the surface area, so our main formula is going to be there, and we can see there's too many letters there. We've got R and we've got an H. So we need to get rid of one of those letters, and H is probably going to be the easier letter to get rid of because that R there is being squared, and that's going to be a bit annoying to deal with. So we need to kind of come up with something. H is equal to something to do with R. And we're probably going to have to use this volume formula here, right? Because we're given the volume, we can get rid of the V. That leaves us with R and H. So let's set that up. And hopefully we can get H in terms of R. So my volume, as I said, was equal to pi R squared times height. My volume was 500. So 500 will be equal to pi R squared H. I need H by itself. So I'm going to move basically my pi R squared over to the other side. Currently multiplication will become division. So 500 divided by pi r squared is equal to the height. So amazing, I've got that first step sorted out. I can now look to substitute that into my surface area formula. So do that over here. So actually I'll do that down here in case I run out of room. So my surface area is going to be equal to 2 pi r squared plus 2 pi rh. And remember that h is going away and it's becoming 500 times pi r squared. I can now look to simplify that, particularly the messy fraction. So let's move the 2 pi r up to the numerator and see what we get. So we've got 2 pi r squared plus, what's that going to be, 1000 pi r over pi r squared. This looks nice. Those pi's cancel, so it's going to make my life a bit easier. And that r is going to cancel out one of those. So that there is going to become 2 pi r squared plus 1000 over r. And remember, 1000 over r can be expressed as a negative power, can't it? So if we flip that over to the top, that's going to be 2 pi r squared plus 1000 r to the power of minus 1. So amazing, I finally got my surface area formula in terms of one of the variables, in this case the radius. I now, don't forget, because I'm dealing with the minimum, the minimum surface area, I now need to get my derivative. I need to find SA dash, and this is going to get a bit messy, I think. So what I'm going to do, I'll delete the question and we can start doing this differentiation. So we need to differentiate from SA to SA dash. So 2 pi r squared is going to differentiate to 4 pi r, isn't it? So 4 pi r, and then I can now differentiate 1000 r to the power minus 1. So 1000 times minus 1 is negative 1000. So that's going to turn into a negative 1000, and my negative 1 will drop to negative 2. So I've now got that part there, and now I need to set it to 0. And then I need to solve for r, which is going to be a bit of a headache, I think. So getting into that, I can think of, maybe this r squared or power of negative 2, maybe I could turn that back into being positive. So let's do that before I sub in. So 4 pi r is going to be equal to, 4 pi r minus 1000 over r squared. And I know that's going to be equal to 0. So this negative thing here, let's move it to the other side, it becomes positive. So that means 1000 over r squared will be equal to 4 pi r. The opposite of times r squared is, the opposite of divide by r squared is times r squared. And that's perfect. So we're going to times this by r squared, which is going to make r cubed, isn't it? So it'll be 1000 minus 4 pi r cubed. And this is perfect because I'm solving for the radius, I assume, because there's only one letter left. I can divide both sides by 4 pi now. So that's 1000 divided by 4 pi is equal to r cubed. And the opposite of that cube is the cube root. So the radius will be equal to the cube root of 1000 over 4 pi. And I can actually work this out. That's going to be 4.3 centimeters. And that there was rounded to 2 decimal points. So now that I've got that, I haven't quite answered the question. Remember, I specifically said to find the dimension. So I now need to find the height. And remember, we've got a function for height here, haven't we? So height is equal to 500 divided by pi r squared. Let's substitute in the r to find the height. So 500 divided by pi times 4.3 squared. Putting that into my calculator, I got 8.61 centimeters, and that there had a 2 dp rounding. So we're now on to question number 55. Question number 55, we'll do I first and then I. Again, it's a third I question they've had, so hopefully you're familiar with them and what that means now. So basically we've got a curve here and we've been asked to find the x-coordinate of the local minimum. So this part's nice and easy. So we know the x-coordinate of the local minimum will occur when the gradient, so when y dash is equal to 0. So we need to go from our original function to our gradient function. So y dash will be equal to that derivative. So 3x cubed will differentiate to 9x squared. Minus 9x squared will differentiate to negative 18x. Negative 27x goes to negative 27, and the 4 goes away. I now set it to 0. So 0 will be equal to 9x squared minus 18x minus 27. You could mess around with this. You could probably take out the 9, factorize all that sort of stuff. but it's a quadratic. Just bang it into the graphics calculator, I think. So here, A is equal to 9, B is equal to negative 18, and C is equal to negative 27. And when I do that, I get two answers for X. X1 is equal to negative 1, and then X2 is equal to 3. So my cubic has two turning points, negative 1 and positive 3. The only issue is I don't know which one is going to be the maximum, or sorry, the local minimum, which we're looking for here. But what I do know about the local minimum, so remember your second derivative test, that's normally what I teach my class in terms of my differentiation skill, but my local minimum will occur when my second derivative is greater than 0. So that there will give me a minimum, and if my second derivative is less than 0, that there is going to give me my maximum. So what I'm going to do here for both values, x1, x2, I'm going to put it into a second derivative to tell me what that's going to be, and then from there I can classify each point as a minimum or a maximum. So let's find a second derivative now. So y dash dash is going to be equal to 18x minus 18. So I did that by differentiating my y dash. I can now substitute in both of those. So if y dash dash when x is equal to negative 1, so that's going to be 18 times negative 1 minus 18, which is negative 36. Y dash dash when x is equal to 3, that's going to be equal to 18 times 3 minus 18, which is positive 36. So I've got my two values, and now I just need to classify which one's which. So I've actually just realized I forgot to write down 1. So this here is actually the beginning of II, isn't it? So which one is which is the next question. So I guess this one here is negative, which is what I'm not looking for, I think, because the negative one means it's the maximum. So that means the bottom one here is going to be the minimum. So let's talk about each of those. So as y dash dash equals to 36, which is greater than 0, we know that the local minimum will occur when x is equal to 3. Perfect. So we don't specifically need to talk about the other point, the maximum, which is x equals negative 1, because we weren't asked about it. But if you did throw in another sentence linking that to the maximum part, then you wouldn't go astray at that point there. So that wraps up all the excellence questions for this 2024 exam. I really do hope you find these videos useful. Keep an eye out on the more videos that are going to be coming out in relation to these exams. And don't forget, check out the link in the bio if you're wanting the other 54 kind of excellence questions that I've got there for you.